Oh my goodness. It's definitely a Monday right after a holiday because it was like a zombie eat the brains. Hi. Well, welcome back. We're on part 2 of section 5.2. The first part we looked at the median. Today we're going to look at the altitude. And when I say the word altitude, what do you think of?
Height.
Height. How high up is something? How tall is the building? How high is the tree? How tall am I? Not very is the short answer to that one. How high is the airplane up in the sky flying? What's its altitude? The question is, how do we decide what that distance is? Well, they don't actually do this, but the best way for you to picture this is, okay, imagine the airplane. It's flying up there. You picture it? Now hit pause. The airplane isn't moving anywhere. It's not falling because we've hit pause. It's just kind of hanging up there in the sky, right? You got that in your head? Yeah. Now take a string and tie it around the airplane and pull the skirt string real tight down to the earth and make sure that it hits the earth right at a 90-degree angle. You got that?
No. Straight line.
Picture that? So you got this airplane. It was flying. You hit pause, so now it's just kind of hanging out. And then you've taken the string, you've tied it around the airplane, you've pulled the string real tight all the way back down to the ground. You're making sure that it's a 90-degree angle.
So it's like this now, the plane?
The plane is just hanging there. We've tied it around the center and then we've pulled it straight down. The string is straight down. Okay? The airplane's still hanging there. It's just kind of hanging out. We've defied gravity because we're awesome. Okay? So you have this string. And then you figure out how long the string is. That's the altitude. That's what they're doing mentally or with lasers and radar or whatever to figure out how high something is. In a triangle, the altitude of this triangle is the segment that goes from a vertex. Now get this. It goes to the line containing the opposite side. It doesn't necessarily go to the other side. It goes to a line that contains that side. Wait, we'll draw a figure in a second. And it does that at a right angle. Okay? Toward the bottom right of your notes, there's a blank space. We're going to be Taylor Swift, and we're going to go to the blank space and draw a shape. Look, last time I had I sang it and it was like hilarious and funny and stuff. I failed this time around, sorry. Okay. Great laugh. What I'd like for you, please, in your blank space is to draw me a triangle. Not any triangle, but an obtuse triangle. But not in any way. I want the long side. It's not sitting on the long side of your obtuse triangle. It's sitting on one of the short sides of your obtuse triangle. It's going to look a little something like this. You do not need this particular thing. Any old straight edge would do. The edge of your paper, the side of your cell phone.
Oh, I didn't think about that.
A ruler.
Phone.
All right, there is my obtuse triangle, sort of sitting on one of its short side. It looks like it's going to fall over at any moment. And for a lot of you, that's making you go, oh dear God, this poor triangle. It's exactly how I want this triangle to look. All right, if I were drawing the vertex of this triangle, first off, I would need some sort of right angleatron, something that would give me a right angle. And the easiest way for you guys to have a right angle if you don't have one of these cool triangles is to grab a sheet of paper, like a hall pass. Hi, guys. And we're going to go from this vertex toward this side, and we need to hit at a 90. Wait, that's not going to be a 90-degree angle, because I need a 90-degree angle to look like this, and there's no way that's going to look. It's not hitting the vertex at all. Well, remember the definition said the line containing, which means I get to take my straight edge and make this side longer by tracing a line over it. This then is the line containing that side. That's the ground. The altitude then is going to be the line that strikes this at a 90-degree angle and comes from this vertex. So I'm going to take my right angulotron, line it up very carefully. I'm holding it really firm with this other hand, and boom, there's my altitude. Okay, and that would be that string that we imagined at the very beginning. Okay, so the airplane would be up here at that little point, and there's the string that we tied around it. We dropped it to the ground. We made sure it was a 90-degree angle, and however long that string is, that's the altitude. Okay.
But
How would we do that for one of the bottom ones?
Oh, great question. What if we wanted to do this one? Well, same idea. We're going to go now to this side. Line it up. There's my 90. Trace it. This one actually hits the side, so that's no big deal. We may have to extend this line a little bit.
would it be 0 all the time?
I'm sorry, one more time?
Would it be 0 all the time?
Oh, 0. I'm just using that to help me get a 90-degree angle. That's all I'm using it for.
No, no, I'm talking about the bottom right thing. Since it's on the line, would it be 0?
I'm not sure I fully understand your question. But this vertex is always going to be on the line containing this side. And so what's important here is this area right here, that it be 90. Nothing else is really important other than that angle right there is 90 degrees. So if I took a protractor and measured that angle, I'd get 90. That's all that's important. Okie doke. Now, because triangles have 3 vertices, they have 3 altitudes, and the point of concurrency, that is where all the 3 altitudes meet, is called, hi ladies, thank you. It's called the orthocenter. So the point where all 3 altitudes come together and meet and have a party is a club called the Orthocenter. Now the rest of this page has an example to find the coordinates of the orthocenter on a Cartesian grid plane, and it looks very intimidating, the amount of work that they've put. So what we're going to do is, we're not going to read this, we're going to do our own example. But we're going to pull from here the 3 big steps that you need to perform in order to find the circumcenter. Excuse me, the orthocenter. The first step is find the equation of an altitude. I know this example says the altitude, but because they've given you a very specific altitude that they're working with, I said an altitude because in truth, you get to pick which one you want to find. We're going to do that step twice. Whoops. Sorry. After we have found the 2 equations for 2 of the altitudes, you only need to do 2, you don't have to do 3. We're going to solve the system of equations. Whatever the solutions we get from that solving, that is where the altitude meets, and that is the location of the club called the Orthocenter. Ready to give it a shot? Sort of, kind of, maybe?
Sure.
All right, let's try it. Please ignore this first sentence. It was supposed to be at the bottom of the page before. I don't even know with my printer some days. It just prints where it wants. All right, so we are going to find the coordinates of the orthocenter. First things first, what is the orthocenter? Flip back. Find orthocenter. What is the orthocenter?
3 altitudes which meet at a point.
Which meet at the point. So the orthocenter is where the altitudes meet. It's where they meet to have a party. So I need to draw this triangle. I need to find some altitudes, and I need to figure out where those altitudes crash into each other. Here's my 3 points, and I'm going to plot them. Now, if I notice, my biggest number in here is a 6, and if I look at my plot, these numbers go up to like 14, 19, they're really big. So what I'm going to do is, instead of following the scale that it gives me, I'm going to rewrite the scale. And I'm going to make every 2 numbers on my scale be one number. Okay, you can do that anytime you want. You can always change the magnitude. Huh? Yeah, I mean, yeah, if it helps you, go for it. If it doesn't help you, then don't, or if you try it and you realize, oh, that didn't help, I just made it a mess, start over, no big deal. All right, I'm gonna plot my points. La 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 la, plotting points. Okay, I have my points. Let's try that again. I have my points plotted. Now I'm going to connect the vertices of my triangle, and on this part I'm going to be very, very careful. And what I'm trying to do is make sure that I'm going through where the grid lines are crossing each other, okay? So that my line can be as precise as possible. Okay. I'm going to do that for both of these. Again, do my very best to make sure that my pencil is crossing through where the grid lines intersect. That'll give me the cleanest and the most accurate read when I'm doing these drawings. All right, from the front side, our first step was to find the equation of an altitude. We get to pick the altitude. The first thing to do to pick the altitude is, please pick one of the sides that your altitude is perpendicular to. 3 sides of triangle, you can't be wrong. Pick any side that you want. GI. GI? GI. Okay. HI? That's all right. Okay, so we're looking at this one, HI. Our first step is to find the slope of line segment JI. I'm going to zoom in real close on this side. Oh, sorry, HI, not JI. I'm sorry. HI. Oh, gosh, you can't read that. There you go. Slope of HI. There we go. So I'm going to zoom in real close on this side, HI, and I'm going to find the slope. Not going to go with fancy formulas. Not going to do anything like that. I'm going to use the picture and just do rise over run. First thing I need to ask myself is, do I expect a positive number or a negative number?
Positive.
Positive?
Okay, I guess not. Probably negative.
Well, if I look at the line as I move from left to right, is the line starting to fall or starting to rise?
Starting to fall.
It's falling as you go from left to right. So as we go from this side to this side, the line is falling down. So that tells us it's a negative slope. All right, now I'm going to try to find 2 points on the line that kind of cross right at where the grid lines cross, okay? So I'm going to use point I and that little tiny point that I just put. And now I'm going to count the rise, which is a fall of 2, 1, 2. And then my run is 1. And so the slope of this segment, HI, is negative 2. But I want to write it to preserve that fraction. So I'm going to write that the slope is negative 2 over 1. And I'm writing it this way because while I wanted the slope of that line, what I need is the slope of the altitude. That is the slope of the line perpendicular to the side HI. So I need the perpendicular slope.
Miss, how did you get that?
How'd I get what?
That negative 2 over 1.
I counted rise over run from here.
Yeah, but the rise is 6, right?
That's the point that it's on. I actually counted the grid lines. I had to go down 2, 1, 2, and then to the right 1. So this is how far I went down, and this is how far I went to the right.
Oh, you went to a certain point.
Mm-hmm. All right, so again, wanting to find that perpendicular slope, the easiest way to find perpendicular slope is to create the negative reciprocal. To make the negative reciprocal, change the sign.
I can do that.
I started at negative and now it is,
It's a positive.
okay, and then reciprocal means flip the fraction.
So
which means I get 1 over 2. You know everything you need to know about negative reciprocal. You're a genius. But the direction said, find the equation. I now have a slope. Altitudes go perpendicular to a side and through the other vertex. So this is the point the altitude goes through, and it ends up perpendicular to this side. I have the slope of that perpendicular line, and now I have coordinates for a point. The point 1, 0. I can then use the point slope form of the equation of a line, because I have information about a point and a slope, in order to generate an equation of the altitude. Point slope form is y minus y1 equals m times the group x minus x1. Here is my m. Here is my x1. Here is my y1. And seriously, at this point, my brain is going to take a little nap, and I'm just going to substitute the information that I have.
I can do that.
Good. If this were an AP test question, we'd have 2 points so far. Okay, so we've got a 2. We've got 1 for finding the negative reciprocal of the perpendicular slope, and we've got 2 points for writing the slope intercept or the point slope form and substituting correctly.
Out of like what, 100?
No, I think this question only has like 5 points total. So not bad. All right. We could stop here if we wanted, because all we were asked for was for an equation of the altitude. But we know that the last step is going to be solve the system. I'm going to tell you right now, systems are easier to solve when you have it as y equals stuff. So I'm going to make this equation look like y equals, bless you,
Pineapple, damn.
stuff. Yeah? Y equals stuff. So far, so good?
Yep.
All right. We're going to do it again. Because the next step was find the equation. And you get to decide, again, which side you want the altitude to crash into. The first step we did HI. On this one, which one do you want to do? JI or JH? JH. Alrighty. So we want the slope of JH. Slope of JH is 0 because it's a horizontal line. What would be the slope of a line perpendicular to a horizontal line? One more time? Not 1. Because 1 would have rise of 1, rise of 1, run of 1. Rise of 1, run of 1. It would be some sort of diagonal. You want a vertical straight up and down line.
Undefined line.
It would be a slope undefined, which means our equation is not in point slope form. Our equation is in x equals. We just have to figure out where it goes through. But I have a trick up my sleeve. This is an altitude. Altitudes have to go through the vertex. It has to go through this vertex. What's the x coordinate for that point? 3. And so the equation of the altitude, the line perpendicular to this side JH, is x equals 3. The final step said solve the system of equations. So the next question I have for you is, what's a system of equations? What do you think a system of equations is? Random guess, even at the risk of being wrong.
Y equals 1 half, like the y equals 1 half x minus 1 half,
And another one.
and then like.
And then
or
something
equals
else.
3.
Yeah, you're not wrong. A system of equations is anytime you have two or more equations doing stuff together. And I have two equations. I have this one and this one. And so my system of equations looks like this.
That's it?
We have to solve this.
Okay.
How many variables do I have in my system of equations?
2.
2, which means I expect or need to have two values, a value for x and a value of y, in order to have my solution.
Well, we know that x equals 3.
We already have a value for x, so I can take the other equation, and everywhere I see an x, I replace it with the value of x, which is 3.
Isn't it 1 half?
Yes, and I wrote it wrong because I was already thinking to the value of
The
x.
second one's 1 half.
Oh my goodness, you're right. Thank you. Thank you, thank you, thank you. Everyone okay with that multiplication that I did there in the blue?
Yeah.
Okay. And then 3 halves minus 1 half. Here's how I want you to think about subtracting fractions. I know this is going to look like I'm making it way more complicated than it has to be. Subtract the top numbers and then leave the bottom number alone.
Yep.
If you can just remember that, Algebra 2 and Calculus is going to be so crazy easy. The teacher's going to look at you and be like, oh my God, you're a genius. And you'll be like, yeah, I know. And so y equals 2 over 2 or 1. And so your final answer would be coordinates of orthocenter are 3, 1. And now you have all 5 points on your AP test question. Questions, comments, concerns, suggestions?
How do we get x equals 3?
How did we get x equals 3 when we were looking up here for the slope of the altitude, which was the line perpendicular to JH, the base of this triangle? We had to find the slope perpendicular to a slope of 0, which you guys said was undefined. And every undefined line has an equation of x equals and then a number. As an altitude, I know it has to go through the vertex of my triangle. And so this is the line that we're creating the altitude for. It has to go through that point, which is the vertex, and the x-coordinate of that point is 3. And so the equation of this altitude
Must be 3.
must be x equals 3.
And for, what is it, the other slope, when we created our y equals 1 half x minus y 1 half, we got the slope of negative 2 over 1. I know that you said since it's negative, we can use that, but how'd you get that?
How did I get the 1 half?
Yeah, because, I mean, if you
Uh-huh.
counted the rise and run from I to H, you get 6, and with a run of 2.
All right, so let's go back and just double check to make sure I'm using the right slope. So 1, 2, 3, 4, 5, 6. 1, 2, 3,
Oh,
which simplifies down to negative 2 over 1.
oh, it's because I counted 2.
Okay. And then the negative reciprocal, which is change the sign, flip the fraction. Thank you. That was a really great question. Making sure that we got it. We got it okay. All right, that's all I had for you today. Thanks.
Oh, smash that like button. See you in the next episode.